Welcome to Study Loop.
In this problem, you have two lenses that have a focal length of 0.8 centimeters and a focal length of 2 centimeters. It tells you in the problem that you have an object placed in front of the first lens of 0.9 centimeters distance away, and that the image is a virtual image, which is why I've included a negative here. This tells us it's a virtual image. It's appearing to the left of the second lens. And we want to determine what the distance between these two lenses is. So in order to figure out that distance, we need to know what our distance of the image is for the first lens and what the distance of the object is for the second lens. So we want to solve for DI1 and DO2. So we can go ahead and solve for DI1 first. The order doesn't really matter. But you can use the thin lens equation, which is 1 over dO plus 1 over di equals 1 over f. And we can solve for di by doing 1 over di equals 1 over f minus 1 over dO. And then we can inverse the left side and then inverse the entire right side. Again, because I'm talking about the first one for right now, I'm going to add little ones for clarification. And then this becomes 1 over 0.8 minus 1 over 0.9. So 1 over 0.8 minus 1 over 0.9 gets you a image distance of 7.2 centimeters. So that tells us that this is 7.2 centimeters. And then using the same equation, but we are then going to solve for dO, I can say 1 over dO equals 1 over f minus 1 over di, and then dO equals 1 over f minus 1 over di, and then adding 2's for clarification. We get 1 over 2 minus 1 over negative 100. So that's 1 over 2 minus negative 1 over that gets you a distance of the object of 1.96 centimeters. So this distance is 1.96 centimeters. So all in all, the distance between these two lenses is 1.96 plus 7.2. So distance between is DI1 plus DO2. So that gives us 9.16 centimeters. And that would be for part A. For part B, it's asking for the angular magnification. For the angular magnification, we're going to be using the near point distance for the eye, which is 25 centimeters, about. So I'm going to go ahead and give myself a little bit more room here. And we're going to be using the angular magnification equation. And for that, we're going to need the image distance, for the first object times the image distance of the second object, but in this case, instead, we're going to be using the near point of the eye, and then divided by distance of the object for the first lens and distance of the object for the second lens. So this becomes DI1, which was 7.2 centimeters. The near point of the eye is 25 centimeters on average. DO1 is 0.9 centimeters, and DO2, we said, was 1.96 centimeters. Again, this is a ratio, so all of these units are going to cancel out, and you end up with a magnification of negative 1/0